Alright, so hopefully you're feeling pretty confident doing just the algebra when you see an equation with an addition sign, or when you see an equation with a subtraction sign, knowing that you can do the opposite of addition, which is subtraction to remove things from one side, and the flipped would be said as well. So we're going to write and solve equations. So here we've got a new element where we're not just solving an equation, we're also having to kind of come up with it on our own. And like I always say, this is the most challenging part of doing some of this algebra, because you're actually having to apply it and be way independent. So these are the types of problems where you should be spending more than a moment on it and really trying to fight through them, because when you get through these, it really feels great to get your right answers. Also, seek partners on stuff like this. Work on, tag team these. But make sure you're thinking about it and not letting that other person do all the work. And vice versa. Write and solve equations for the following problems. A number increased by 5 is, okay, you can circle that, is, and we also know is equal to. So I know that I'm going to have an equal sign. And maybe I like to deal with the 42 on its own, because I'm like, well, something blah, 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 blah is equal to 42. Got that part in there. And by reducing the total number of parts that I'm looking at, maybe I feel less overwhelmed if I chunk this. Now let's think about what we would have done in the earlier section. A number increased by 5. If I only did that, I'd be like, okay, we've got to have something more increasing it by 5, which means I had something to start with, and I don't know what that is, so I guess I'd use x. So basically, a number increased by 5 is 42. Now, we're being told to write and solve this, and from here on out, when it says solve, I'm not going to put the word algebraically. The assumption is you show your work. So here I am subtracting 5, and x is 37. Now, on here, for the check deal, maybe we don't check it in the original equation, because we actually have a word problem to check it with. Now, if I had 37, and I increased that by 5, I would get 42. Cool. So I'm revisiting the word problem, reading it through my mind, and making sure that logically the answer of 37 agrees with adding 5 to it to get 42. I think that's enough to make this an OYO problem. Give this a go, and I will go ahead and put work up for it in about 5 seconds. Alright, so maybe you chunked it into different parts. If you have 3 minus y, that's not correct. A number that would be 3 less than has to have something to start with. And if I want to get y by itself, I would add 3 to both sides. Instead of showing 28 equals y, I feel comfortable jumping right into flipping it within this step. If you don't, just show that in-between step. And then I'm like, okay, well, 25 is 25 3 less than 28. So I'm plugging my value back into the word problem in my head, and I say, yes, 25 is 3 less than 28. So that works out. The sum of 3 consecutive integers is 12. That means that if I want to do this correctly, I have to know what all these separate words mean. So, figure them out and see if you agree with me. Pause. Well, what sum describes is addition. Things that are consecutive are back-to-back, like the numbers 1, then 2, then 3. And then integers would be counting numbers, which might also include negative values, but not necessarily. Now, you can do this through trial and error, and let's do that as well. Let's just try that out. Write the words trial and error out. If I had 2, the next number would be 3. So we can try 2, 3, because after 2 comes 3, and after 3 comes 4. So these would be definitely consecutive integers, and then if I add them, I would get their sum. So 2 plus 3 is 5, plus 4 is 9. Well, my target was 12. Well, that's no good. So let's decide. Well, do I increase it a lot or a little? Like, would I immediately jump to 1,000? Absolutely not. So instead, I'll start with 3, 4, 5, and 3 plus 4 is 7, plus 5 is 12. Awesome. We are done. That's what you think, kid. We can do this algebraically, and yeah, trial and error got us there quickly. But today, as the teacher, I'm using trial and error as a strategy that's, really an awesome plus if you need to get to the end result. But it's also another awesome plus to help us see how we can use the algebra. And you're going to want to be able to use the algebra for ones like this, where it's way more difficult and you can't just figure them out in your head or by checking two different answers. Now, if we were to start with any number, we would have no idea where it was. So I'm going to use the variable x to indicate the very first number. So maybe in this case it would be 2 or 3. And if I wanted a number that immediately followed x, well, first we're going to add because we're doing the sum. So if I had a value of x, my immediately next number would be x plus 1, because it would be 1 more than my starting number. We're still doing addition, but then the next value after that would be another x, but this time plus 2. And all of this would have to be equal to 12. Write that nicer than I just did. I'm just running out of room. And the only reason I showed parentheses in this step is to help us more clearly see it. So now I'll get rid of these parentheses. X plus 1 plus x plus 2 is equal to 12. And now we have a new combining like terms problem. I scan through everything, I see x, x, x. So I have the variable x for a total of 3 times. I scan through and I look for my numbers, 1 and 2. And then 1 plus 2 gives me 3. And then 3x plus 3 is 12. Now, really, we can now use reason to figure out what this first value would be, but I'll show you how to do this. This is really a multi-step equation. So we're going to subtract 3 from both sides. 3x would be 9. Divide both sides by 3, and you get x is 3. And it's not enough to just say x is 3 because they want to know what the numbers are. So if x was 3, then my next number would be 3 plus 1, which is 4. And my last term would be 3 plus 2, which is 5. And that would totally agree with the way we did it through trial and error, where this x value of 3 is what we started with. So consider this the most challenging thing that you'll do in this section. Real world problems. So now we've done some problems with some words, but these are getting heavier with the word problems. In the 14th century, the 1,000-mile Great Wall of China was repaired and the wall was extended. When the wall was completed, it was 2,500 miles long. How much of the wall was added in the 1300s? Now, you're probably pretty quickly being like, okay, well, I'm just going to, figure out the problem. But the whole idea is that we're supposed to do these algebraically. So when I read this, I'm like, well, it was 1,000 miles to begin with, so that's its starting point. And then if they're going to add on to it, that would be my change, so I'm going to add on to that. And then after those changes, it became 2,500 miles long. If I did 2,500 minus 1,000, that's just not correct as far as showing the idea, because the way the word problem is presented is this is more of a addition problem in nature. So from both sides, I'd subtract 1,000. We can go through problems like this on with the group too. That's 1,000, not a 1,600 there. And then here, this would become 1,500. And it is a word problem, so don't forget to box it with the unit of miles. MI is also an okay abbreviation. And it doesn't say to check it, so we'd be okay. But we could reread it and be like, okay, well, it's 1,000 miles. It got repaired, and it was extended by 1,500. And if I added 1,000 and 1,500, I'd get 2,500. In a recent year, 1,286 female deer were born in Lewis County. That was 93 fewer than the number of male deer born. Pause the video, make this an OYO, and try to set up your equation as best you can. I'll start talking about it in a moment. Here's how I think about it. There's female deer, and then there are male, but there's 93 fewer females than there were males. Feel free to, go about this the wrong way and then check it in the word problem and then realize you just have to change your thinking. So you might want to say female minus 93, but really, because there were more males, it would really be 1,286 equals M minus 93. Because that's the only way I can set this up and get a larger value for the men. Add 93 to both sides, and we'd have M is equal to 1,379 male deer. Reread the problem and make sure they're not asking you something like, what's the total number of deer? And if I figure this out, I'm like, well, 1,286, that value is 93 fewer than 1,379. Now, those word problem concepts were probably challenging, so stick these out, ask me questions as you're doing these, and revisit and even rewatch parts of this video to see if it feels better on repeated viewings. Again, the goal for these sections is to be able to do problems like this, not the word problems, in less than 20 seconds. And these equations over time need to be like muscle memory.